ANSYS Simulation, Lecture 13, Flow Simulation using Fluent. This problem is about mixing of hot water and cold water into warm water and come out at outlet. The first thing we do is loading the software. Here, ANSYS. And then we'll enter Workbench. And the first interface we see will be Project Schematic Interface, which organizes all the procedures on this interface. So we drag Fluent onto geometry and edit mesh. And this will be a meshing procedure of ANSYS. There will be two things that we'll do. The first thing will be defining inlet and outlet surfaces. And the second thing we do is meshing the geometry. So first of all, we can mesh, we can define the name of the inlet. We'll define it as inlet hot. And the other surface is inlet cold. And we'll name the outlet outlet. So these are the surfaces that we define as a name selection. So we mesh the geometry and finish with this procedure and close the procedure and go back to schematic and enter Fluent. This page will be defining your hardware, and we take the default and then enter Fluent interface. The first step will be general settings. The second step will be the initial conditions. The third step will be the boundary conditions, inlet and outlet conditions. Step 4 will be the goal and monitors. Step 5, calculation and running the solution. And step 6 will be the result. And for the first step, we take the default, because here we can check the case. We can scale the geometry or display the meshes. We can define the velocity formulation as absolute velocity or relative velocity, or the pressure-based or density-based fluid, and whether it's steady-state flow or transient flow. We can change units if you like and define gravities, but we will take default and move into second step. The second step will define what other procedures that you will include in the problem. In this case, we'll include energy equations. We will check the checkbox and the energy equations will be on. For the viscosity of the fluid, we take the default. And for the others, we'll all take defaults as off. So we only check on the energy equations on these models, because we have hot water and cold water, so we need to check the energy equations on. For the materials, the default fluid material will be air, so we need to create another material from Fluent database, and we'll choose water liquid and copy it onto the procedure. So this is the default air, and this will be the chosen hot, liquid water. So for the next item of the second step, we have to define that the volume contains water instead of air. So change into water. And as a rule, I always choose outlet as the main direction. So I'll define it as a X direction in the outlet according to the geometry. So we have finished with the second step, which we define an initial condition of water in the channel and in X direction. In the third step, we'll define the inlet properties. For the hot inlet, we would name it as mass flow rate. In the mass flow rate, we'll define it as a normal boundary at 0.5 kilogram per second mass flow rate. And the temperature would be 90 degrees C or 363.15 degree K. So this would be 90 degrees C, and the flow rate would be 0.5 kilogram per second at the inlet, hot inlet. For the cold inlet, it's also a mass flow inlet. And we also choose normal boundaries. And the flow rate would be 0.5 kilogram per second. And the temperature would be 393.15, which would be 20 degrees C, a cold water inlet, and a flow rate of 0.5 kilogram per second. And for the outlet, it is a pressure outlet, and with the pressure of atmosphere pressure. So we'll leave it as a default, atmosphere pressure. So we have finished with the third step. And also for the dynamic mesh, our boundary does not move, so we do not check dynamic mesh. And for the reference values, we take the defaults. So we have finished with the third step. For the fourth step, the goals, and we'll define the pressure velocity coupling equations as defaults, and solution controls will take defaults. And for the monitors, we'll create volume monitors, especially for pressure, static pressure at the volume, and we'll monitor the iterations and convergence at window 2. And we'll also create a volume goal of velocity, and we'll monitor the procedure of iteration and convergence at window 3. And we'll increase a volume goal of temperature, and we'll monitor the iterations and convergence at window 4. You can add other goals, but now we'll add another surface goal. We'll create a outlet surface goal of temperature, because it is very important that we know the outlet temperature, and we'll monitor the iterations and convergence at window 5. So now we have finished with the step 4. And for the solution initialization, we use hybrid initialization as default and initialize. And for calculation activities, we let it save all the iterations, and it will run 100 iterations and proceed with the calculation. And I'll stop the recording because it will take a little bit of time for calculation. The calculation has completed, so I close the Fluent interface and enter ANSYS post-processor. And I can generate a contour plot for inlet temperature, and then I'll generate a cold inlet temperature, and then an outlet temperature. Of course, you can generate any other items, for example, pressures or velocities. So now I'll generate the surface temperature of the wall. So now I have the temperature distribution of the whole volume. But for the present time, I will hide the plots, and I'll generate a streamline or flow trajectory. The streamline will be from the outlet, and it will be forward and backwards. It will be 40 points and equally spaced for velocity. And for the symbol, I'll choose show symbol, and it'll be a ball. Okay, and this will be the streamline, and we can play the animation of the streamline, but it is too fast, so we let it play slower. This is a slow streamline to play. So this is animation of the velocity. So we'll stop that, and you can put back the contours, and this will be the temperature distribution here. So you can see that the surface is cold at the right and is hot at the left, and actually it is not well mixed. At the outlet, the temperature distribution is also not uniform. So we can see that this problem is about mixing of hot and cold water into a warm water. And the purpose of this lecture is to introduce the structure of the 6 steps of solution in Fluent interface. And also we include an energy equation in the flow. So the main difference of this lecture from the last is that in the last lecture we talk about only flow through a tube or a pipe. In this problem we talk about energy equations, or hot water and cold water, involving thermal problems in a fluid flow simulation. So that's the main purpose of this lecture.